Hello, my name is Cecil Bowe, and I'm here with Chuck Cottrill. And what we're going to do is we're going to have a quick interview for assignment 10 on the future or dealing with a professional in the data analytics field. So the gentleman right here that I'd like to interview is Chuck Cottrill. He is a principal software engineer with AT&T. So Chuck, could you go ahead and introduce yourself and sort of say something about your background?
Sure. Okay. Background. So I Chuck Cottrill. I've been a big data software engineer for 3 years now at AT&T. Let's see. I got an undergraduate degree in math, and I've been doing software development for many years, many years. Took a bit of a circuitous route into big data. I was doing location analytics, location calculations, and working on data that producing billions of location records a day.
Okay.
And as part of the creation of big data, they needed one of the big things was not just analyzing what people were doing, but also where they were doing it at. So, how did I get into big data? How did I get into data analytics? Well, I've always had a passion for math, so the statistics part of data analytics, the predictive parts have been intriguing.
So you think statistics is really important?
I think statistics is crucial. If you look at any of the machine learning techniques, if you don't have a good basis or understanding of probability and statistics, you're not going to truly understand things like survivor bias or any aspect of, if you look at like neural networks, if you look at the statistics or the underlying sigma function, if you will, of a neural network and how it triggers, you have to understand those things. It gets back to something that I'll refer to Joel on software, and he has a blog on leaky abstractions, and I think that is very informative. But how do why software and not math? Why the intersection of the two? Well, because software is very pragmatic or applied math, and so it's math with a purpose.
Okay.
And I like that. So does that answer your question?
No, it answers perfectly.
Okay, great.
Let me ask you, so I guess you answered the second question, why did you choose the sector? You sort of slid into it based on it.
You like to, and you hear so many people say, I set a goal and a path for my life. It was really just a fortuitous intersection of paths. I got a degree in math because I was good at it. I went into software because at the time my number one thing wasn't necessarily teaching. It was more, well, I want to do things and I earn a living, and software was very intriguing. I look at software, at writing programs, as an instance of a proof of an algorithm. So for me, it was a way to get paid to write proofs. Very pragmatic proofs.
Keep going. Let me just make sure it's still recording. Good.
If you want to pause it there, and then we can cut.
No, we can keep going. So one of the things so that's great. So one of the things I want to say was, how do you use some of the methods and skills and techniques for like text analytics, data analytics in your daily work?
Text analytics, data analytics. Well,
a lot of you're parsing a lot of data.
A lot of the data that we get, at least in the areas that I've been working in, they're not true free format text analytics in the way you might look at scraping a blog or scraping chat analytics or that sort of thing. Although there are people that I work with in this same group that do that. But our challenges are more like free-form text fields and more regular data. So for us, we get a lot of, and one of the values of working at AT&T is such a huge organization. We have such a breadth and scope of data. But we'll have data that, though it's in a regular format, isn't clean.
Mm-hmm.
So you have to trim it, clean it, sanitize it.
Yeah.
One of the exciting things that I'm working on this year is a data ontology project. Data ontology, where we're looking at for the hundreds of different databases, not data tables.
Mm-hmm.
Some of these databases have thousands of tables.
Mm-hmm.
And so what we want to do in the data ingestion group that I'm in is we want to look at how to do validation in a more automated fashion. And so we just finished an initial data validation tool that will use the statistics and trend the contents of any particular column in any particular table over time to detect, use machine learning or predictive analytics to say, is there a problem with the data that we are trying to ingest?
What kind of machine learning are you using, like neural networks, SVM, or decision trees, or
decision trees, random forests, a number of different techniques like that. Bloom filters, we've used a few of those. A lot more. There's a lot of, if you will, micro text. Like I say, you may have a couple of key values embedded in a comments field that refer to other non-linked databases. So you have to use, text processing to look at and discern, well, what kind of an ID is this? What other database might this refer to? So very microscopic kind of thing. But we're also looking at ways to examine the names of columns and look for references between tables, that sort of thing. And look at the contents of the data and look at the distinctiveness of the data and that sort of thing. Other groups, I've helped out a couple of folks with advice on other kinds of things like location things, like insights into where people are at and how they're moving. We've actually done some IP or patent work using the data.
Yeah, could you talk about, because you've got some really interesting patents.
Well, it's some of it I can talk about, a lot of it I can't, not till it's published, but we've done a couple of IP on fraud, where, if you look at where you see a person's cell phone around the country or around the world. So if you see it in two places and those places are far, they're very far separated by enough distance that
the SIM has been copied.
They'd have to have a teleporter device, right? So we patented an algorithm and a system for detecting potential fraudulent cloning of telephones.
Are you working on a teleporter device also?
I'm using the technology to try to find those people who have teleporters, so I can go find one.
Okay, great. So
so we also are in concert with a gentleman who Sheldon Meredith. We just had published a patent that's using some electronics to speed up sorting. And sorting, as you well know, is crucial to anything that you might want to do with data. You can hash, you can sort. There are various ways of bringing together across, if you look at data, you can look at little data, small groups of data, and you look at huge groups of data. And so when you want to bring together billions or trillions of records, you have to have ways of efficiently doing that.
Great.
And so there are opportunities to explore novel and different approaches to solving those problems. Bloom filters is an excellent way.
What particular software or programming languages, if any, do you use? You just keep going.
Oh, software and programming languages. Python. Python is great for, since it's interpreted, but it compiles and it's fairly efficient. Python is an excellent language for experimentation. R is a great language.
Mhm.
Python has lifted the Pandas library and NumPy.
Exactly.
There's a couple of excellent toolkits.
Was your introduction to the pandas? I'm assuming that your introduction was it with like a machine learning for
A
trading.
machine learning course at Georgia Tech, machine learning for trading.
Mhm.
I had learned Python. I'd started out learning R.
Mhm.
I started the course at Georgia Tech that
Mhm.
we met.
Which,
on
by the
that
way,
same journey.
let's just stop right here. This guy right here is like my resource, my guru. When I have questions about Georgia, about anything to do with like programming or concepts, right here. I mean, this guy, he knows. I don't want to say like he knows it all, but he does. He understands the concepts. I've seen you write code in Ruby, Perl, and everything else. And I mean, an excellent resource.
I think I'm going to jump ahead on one of your questions, but I think you have to be a polyglot programmer to be someone who's well versed in a number of languages and always be growing, always be learning and growing. So I was teaching myself R, and I got stuck on what do they mean by a data frame?
Data frame, yeah.
And then I started learning Python for the machine
Dr.
learning
Bach,
course.
right?
Tucker Bach. And I learned NumPy, and I learned Pandas and SciPy, and they're excellent tools for some aspects of machine learning. And
would you recommend C++ for machine learning?
Depends on the size of the data, but I think depending on what you're doing, you have to find the right tool for the job.
I think C++ becomes a little bit too cumbersome and too manual in nature when you can really do it faster with Python.
When you look at languages like Java and C++, they're very rigorous in their typing. And when you're in exploration mode, which I think you're in a lot of the time, when you're doing machine learning, or when you're...
What's the concept? It's like explore, and it was explore, exploit, right?
Right,
Yeah.
explore and then exploit. And so you've got your Sherlock Holmes investigative hat on, and you're forming hypotheses, and you're saying, well, I wonder if this column is a principal column, if this is important. I wonder if that column, if that piece of data is. So as you're exploring, you want a language and you want an environment and a size of data that is
flexible,
that'll get you an answer fairly quickly. And so you start looking for, well, am I close enough to the edge, if you will, to that 50-50 ratio or 60-40 ratio, that I'm finding interesting patterns?
Yeah.
And you found this too, I'm sure, as the courses you've done. You're investing, it's not interesting when 90% of the data is one way and 10% is another. It's interesting in that 40, 60, 50,
That's where the training, the testing data set, right? Where you can
Right.
Because I think you have like a data set that's biased. I think that's what you just
Sure.
Highly intensive bias.
And it's not enough to find, you want to actually find
nuggets of gold.
That bad data, that data that doesn't quite follow your initial hypothesis, because then you're challenging that hypothesis and refining it. And ask questions, if you think you have the right answer, go talk to somebody else.
Yeah.
Tell them what they think. And if they ask a question, follow that.
Yeah. So let me ask you another question. What are some of the misconceptions people have about your field?
Misconceptions. Oh, wow.
As I know you got misconceptions of sales, right? Sales things, what the sales things big data is, and what is really big data.
Well, it's not.
In data analytics.
It's not. A lot of it is linear regression. A lot of it. You think that machine learning is the magic, but it's really it's like calculus. A lot of little tools, right? You think about Q-learning. Q-learning is a fairly simple algorithm at its base. If you think about neural networks, they're really very simple. If you look, it's either on or off, or the sigmoid is kind of on and off, and there's a little bit of gray area in the middle that makes it mathematically tractable. But mathematically tractable. You can turn it into an on or an off, and it's a pretty close approximation. And it is, the power of a neural network isn't that that gate, that on-off is really fancy. It's when you hook them all together in a convoluted neural network that the real power of the function comes out. KNN learners. I mean, you can explain one of those in 5 minutes and somebody can get it.
Yes.
The edges of a KNN learner. You think about linear regression. You extend up out the ends. Well, KNN doesn't assume anything beyond the boundaries of where it's trained.
Right. Yes.
So if you understand a little bit, as you start to understand the data and the distribution of the data, hence understanding the statistics underlying all of it, it helps you understand what should you do at the edges or the boundaries, and how close to overfitting are you? Because as you know,
you
when you're
overfit too much in
exploring
the
data,
training.
you don't want to overfit.
You overfit too much in the training.
You want to just fit.
You'll destroy the test.
You don't want to underfit. You don't want to overfit.
I think we learned that in machine learning for trading when we were doing the stock portfolio. You overtrain too much in the beginning. In the end, you actually lost money over a period of time.
Yeah, if anything, in that course, I lost more money by overfitting.
So let me ask you one last question. Discuss the future trends or future applications, and how do you see them, your area, your field developing in regards to data science or text analytics in the next 5 to 10 years? Which I think we're really in it right now, right? It's really picking up, right?
How is it changing? Well, I think we already see where it's going, right? I mean, you see it, I see it. Google has released TensorFlow. I mean, you look at the things that are coming out of the Apache and open projects. You look at what Microsoft just announced with their AI. They're commoditizing some of the AI. So
you're now seeing billboards about AI now.
Oh yeah, I mean, you're getting, if you think about the AI winter, that period of time from the late 80s to the mid 2000s, where there was really not a lot of. It took real diehards. So when I graduated from college, and this is dating me, in the mid 80s, AI was just going into the AI winter. And I'm really excited that AI and machine learning and AI, as you well know, AI is over here in this area, machine learning is over in the more automated side of. So there's a lot of things that have come out of AI and become mainstream and are really starting to be, we'll use KNN, we'll use random forest, which is just boosting and bagging, right? So people are starting to use all of these techniques that 10 years ago you never heard so very much about.
I didn't hear about it until I got into some of these courses, right?
Right.
So when I first heard boosting and bagging,
what is that?
Where you can boost the car.
That sounds really exciting. Bagging, that sounds really special. Right. And then you find out about one of those techniques or another one of those techniques, and you say, well, that's not that hard. It's really exciting because it's mainstreaming mathematics, I think. And
you hear KNN and you think it's some really difficult concept, but it's really not. Or you hear decision trees, and it all comes down
what's
to entropy.
Decision tree? Making a decision between this alternative and that one.
And coming down with entropy, right?
And somebody talks about simulated annealing or pruning, and you're like, what's that? Is that a gardening thing?
Yeah.
No. It's
Simulated
they're outliers. How do you get rid of the outliers?
It's a simulated annealing, yeah.
And so where do I see it going in 5 or 10 years? Well, I see more folks who understand the fundamental mathematics getting more into using the technology. And so I see the technology becoming truly mainstream. It'll be used everywhere.
Right.
I was just reading on LinkedIn someone saying they're going to see machine learning used for personal assistance and for scheduling assistance and You know, we already see it for spam filters. We've seen that for
Yeah,
years.
exactly.
We're going to see it helping you with security. And so companies are going to adopt it everywhere.
Yeah.
And so the marketplace, I think, is only going to expand for people who understand machine learning, data analytics, how to explore data, how to apply statistics, how to apply with wisdom, with understanding of the underlying mathematics, how to apply these things. For me, it's almost, I mean, I've been in software for a long time. So for me, I'm excited for the next generation of folks because they're going to have at their, just to reach out and use in a library, things like neural networks, which they're becoming, you know, just, I mean, we just had a hackathon, and someone who just graduated with a degree in math from Georgia State is using neural networks like they've never, you know, like they've been using it forever. And that's what's going to happen is you're almost going to have these tools coming out of the undergraduate level to be able to, you know, to function as a software engineer.
Great. Well, okay, so I think we've got like we've probably got more time, but I mean, probably there's a lot more we can talk about, but I'd like to thank you.
I appreciate your time.
No, I appreciate your time, man. It's always good to sit down and talk to you and just get insights on the future of data, text analytics, and big data in itself.
So I always like to turn it around when someone asks me questions. So you finished the OMSCS program, and you work in RAN engineering. Have you been able to use any of the tools and techniques that you've already learned?
So I've already used that in the sense that I'm able to go ahead and go through some of the data, build some data sets, and put it through Weka and things of that nature. One of the things is that I found that it's helped me have a better understanding of concepts. Like when you get into meetings and you're sitting down, you're talking about data and data analytics, you can talk, you understand conceptually what it is, where it is they're going, and what it is they're doing, and then you can build on it. So I think it's definitely helped. Like we can sit down there. 3 years ago, I would never be able to have a conversation with you about Canon, neural networks, machine learning, bagging, boosting. But now it's just like second nature because you have to accept that that's where it is and that's where the future of this market and everything else is going. And that's why I'm doing the Oklahoma program, which is working primarily on developing these data and text analytics skill sets.
Sure. So what sort of coursework are you being exposed to in a data and analytics program as opposed to a more computer science?
Well, we're seeing much more programs like classes are based on R, and actually this class that I'm in right now is Intro to Data and Text Analytics.
Okay.
So which is really cool. There's still like more classes where you're going to talk about true data analytics, looking at sets, how you can mathematically manipulate sets to make them more useful. And like we're doing right now, like a PCA, we're doing some PCA analysis, and you're having to transform textual data into binary or numerical data in order to perform PCA, primary component analysis, and to break it down and put it into clustering and all that stuff, and just trying to just work on different concepts continually.
And do you find that the visualization tools that a tool like R brings?
Oh, extremely strong. I mean, even Python, because now you get to the point where you've gotten tools like Weka and things of nature. Now you can take Weka and you can integrate Weka with R, and you can put R with Python, then you can put Matplotlib, and then you can take the Pandas data frame and it can go across the board into R and to Python.
And that's something that I'm really excited about. As I mentioned earlier, was that polyglot, developer, that person who has a vast array of tools, combines Python, R, C, C++, Java, Scala if you want, if you want to use that for Spark, and then some of the open source frameworks and some of the tools like in big data we have Hadoop, we have Pig and Hive for manipulating massive amounts of data. We have H2O in our cluster. And so one of the things I think that I really have enjoyed about software development in my career is it forces you to constantly learn.
Exactly. So when you said it right, so you asked me why would I, after taking classes at Tech, why would I look at taking classes at University of Oklahoma? And for that point is that I wanted to make sure that I grew a total holistic skill set that not only just using a computer science background, but actually getting more. That's one of the things I realized while I was at Tech. I was like, wait, I'm missing the data science background. The data science is
Sure.
not yet been launched for years. It's a perfect program in Oklahoma. It's online format because it allows you to work professionally, and then you're able to sit here and work and develop these skill sets. And not you can use real world data, but not using your actual work data, but using test data from classes and realistic real world data without making that. You can make the mistake on this data, right? You get it into the work environment, you should probably need to know what you're doing at that point. But you have to learn, and you always, so my approach is that each day I say, I want to be better than I was the day before. And I want to learn more than I was than I knew the day before.
Now, your background, refresh me on it, Cecil. I know that you work in radio access network, RAN engineering, but what was your undergraduate or what was your prior education?
My prior education was a bachelor's in applied physics and minor in mathematics from Morehouse College. I also have a bachelor's in electrical engineering and electrical and computer engineering from Georgia Tech. I have an MBA from University of Georgia, and of course I've taken the classes for the computer science.
So you're an excellent example of a lifelong learner, someone who's embraced education as a constant.
I've embraced education, but I don't focus on degrees. Degrees don't matter to me, right?
It's the knowledge.
It's the knowledge. I'm hungry to learn, right?
Right.
Like, so, if it's something that can help me get better or I can learn from it, I don't care about grades anymore.
So now you're doing an online program. You've done an online program. You've also had the brick and mortar in-class program. You and I, we both are experiencing these online programs. What do you see of the future of online?
The future of online, this is the future of online. We're looking at it right now. We're looking at Udacity. We're looking at the Janixes and all these different formats. Because everybody, you have to realize it is a time and convenience factor, right?
Sure.
Online is it, right? Because you've eliminated the excuse, I don't have the time.
Well, in my case, I have 4 children, and so 2 of my children have graduated from college, but I still have children at home.
And you have a very demanding work environment, right?
And a very demanding work environment.
I want to say that yours is more demanding than mine because it is very interesting over here. It's very good. It's a very good concept of what you guys have here. I mean, with the big data, but
and we're going to talk more offline about that. And one of the things that I found, even though when I graduated from college as an undergraduate, is I just couldn't find the time to commit to going on campus.
Drive. So you've cut out the commute. You've cut out the traffic. You've cut out the parking. You just get right there and get right to the work.
I don't have to hunt for parking, which was always the stress of being a father and being a husband,
and then running the class to make it on time,
an employee, and being a working professional, and all that stress. I can do the courses, I can do everything except for the tests. I can do the assignments when I can fit them in, interleave them with life. And then of course the tests they have the online proctoring, so I can even do the tests at the time on the weekend when it's best for me. So the one thing that I miss that I think that is a challenge still for online, and